A very warm welcome to all the viewers. Myself, A.S.Balaji. I am working as a assistant professor in the Department of Computer Science and Engineering in ANAND Institute of Higher Technology. In today's quick learning session, we're going to see about the concept of stack and queue data structure. Before that, we're going to see about what is data structure and its type. We will see the definition of data structure. In general, a data structure is a way of organizing the data in different manner. And also, we can say data structure is a specialized format for organizing, processing, retrieving and storing data. Next, we can see the classification of data structure. So, the classification of data structure is based on way of accessing the data. We can classify the data structure as linear data structure and non-linear data structure. In linear data structure, the way of accessing the data in sequential manner. But in non-linear data structure, the way of organizing the data in unordered form. Next, the example for linear data structure is array, stack, queue and linked list. Next, the graphs and trees are the example for non-linear data structure. Next, we are going to see about the concepts of array and stack with some animation. Stack is the example for linear data structure. The current scenario represents the diagrammatic representation of stack. The stack has only one end, so that all the insertion and deletion operation of the stack taken place through this end. The size of the stack is fixed or static, that means it does not change dynamically. So the stack size deals with the maximum number of data elements that can be held by stack. Next, we will see this current scenario represents how the file of object stacked vertically. This scenario represents how the objects are extracted in order from the top-down manner. Now, in this, the operation of the insertion and deletions are called as push and pop operation respectively. The current scenario represents that is only one object, blue, which is already inserted into the stack. Next, the green element is pushed. Next, the another element is red is going to push. Actually, the stack follows the last in first out manner. For example, if you want to remove the element blue, first you have to pop the element red, next green, then only you can remove the element blue. Once again, I am representing the push represents insertion operation. Next, we will see the pop operation. In this scenario, the red is the element which is lastly inserted. But if you want to remove the element blue, first you have to pop the element red. Next, you have to pop the element green. Whenever you are trying to insert the element in an empty stack is called underflow conditions. In same way, when the stack is full, you are trying to insert an element is called overflow condition. Now we're going to see about the concept of queue data structure. Queue is an example for linear data structure. The current scenario represents the diagrammatic representation of queue. The queue has two ends, rear end and front end. That is, the insertion taken place in the rear end, the deletion taken place in the front end. The current scenario represents the group of people waiting in the line. The queue follows the first in, first out manner. This current scenario represents the queue with one element, blue. In queue, the insertion and deletion operations are called as NQ and DQ respectively. So, the insertion operation taken place in rear end, the deletion operations are taken place in front end. Now we enqueue the element green. Next we enqueue the element red. Suppose if you want to dequeue the element green, first we have to dequeue the element blue, which is inserted first. Next we dequeue the element green. Once again we will see the push and pop operation in stack. Here the stack with the three elements blue, emerald and green. Next I am pushing the element yellow. Next I am pushing the element red. So the maximum size of this stack is 5. Suppose if I want to delete the element or pop the element green, first I have to pop the element red, next yellow, then only green. That is, stack follows the last in first out manner, or we can say first in last out manner. Similarly, once again we can see the NQ and DQ operations of queue. The current scenario shows that there are three elements in the queue. Suppose I want to NQ one more object, yellow. Next I am NQing the element red. So the maximum size of the queue represents 5. Suppose I want to dequeue the element green. First I have to remove the element blue, next emerald. Then only I will be remove the element green. So we will see the dequeue operation. First we have to dequeue the element blue, next emerald, next green, next yellow, next red. So this scenario represents the first in first out manner. Thank you. Thank you once again. I hope that this session will be very useful to learn about the concept of stack and queue data structure very quickly. We will meet again in some other quick learning session with another new concept. Thank you.